Hey, welcome everyone to Tech Bytes with Tech Scalable. Today we would understand what does the terminology microservices means. So microservices is nothing but a way of architecting our application. The way we structure the application into multiple services, we would be breaking our food to go application into smaller and interconnected services. In the last video, we understood that our food to go application constitutes of order management service, a kitchen management service, restaurant management service. So these individual services would be deployed separately in different infrastructure, and they would be interconnected with each other to talk, to communicate with each other. Each of the services would be implementing different functionalities like order management, kitchen management, customer management. And these applications, when you split into multiple components like individual services, they are no more a big, huge application. Rather, they are very mini application. And we had seen how the architectural diagram shows the hexagon as the outside boundary of our application. We would have a dedicated hexagonal architecture for each of the business logic which we would be implementing. So let's see how does that look like. So in this picture, if you see that we have broken down the bigger hexagon into smaller hexagons, we have a separate order management, a restaurant management, a kitchen management service, and a delivery management service. Notification service resides here, accounting, the payment one is here. The multiple API gateways which we had for interacting with the courier and the consumer is residing separately, and the web UI is also residing separately. And you can find that this REST API, so when we have multiple microservices, they need to interact with each other. So they would be calling each other's REST API, and they would be talking to each other and completing the entire sequence. Just imagine a consumer orders the food. If the request will go to the API gateway, it will go to the restaurant service, it will go to the order service, it will run through all of the different microservices and would complete the order for a particular consumer. API gateway would be routing the requests to individual services, and whenever a service needs a specific type of database, could be that a microservice is more better working with a transactional database or non-relational database, we can choose individual types of databases for each type of microservices. And the best part to it is that every microservice will have its own code repository. So I'll have different code repositories to which my individual teams would be pushing in their code, and they would have their own dedicated CI/CD pipeline, which would be building, testing, and deploying only order management, only restaurant management, only delivery management. Suppose I am belonging to the team of order management, these two things would be functioning. I would just go ahead and deploy the order service with the newer feature changes. So I'm not impacting the entire system. Rather, I'm just individually deploying or upgrading or updating individual services without impacting the whole application software. When we think of scaling a microservice, the scale cube and the microservice funda comes behind that. There was a very beautiful book, The Art of Scalability, written by Martin and Michael, which provides us the basis of scaling microservices. So they depicted that there are three axes in which your application would scale: x-axis, y-axis, and z-axis. X-axis is the horizontal duplication, where you have n number of replicas of the same type of service. Just imagine the order management service would have multiple instances 1, 2, and 3. And because there are huge amount of traffic coming to the order management service, I fit in a load balancer in front of it, and I route the traffic or split the traffic across n identical replicas of my order management. So this x-axis is the common way in which you can scale to multiple replicas, but these instances would be the same instances. That's the reason the word replicas. And there would be a load balancer in front of it to distribute the workload. This would improve the capacity which we can accommodate, the amount of traffic which we can serve, and the availability of the application. If one replica is down, still then my application would be up and running for the customer. Same way, if we look at the z-axis scaling, I may be running multiple instances of the application, but each instance would be just responsible for some subset of the information, subset of the data. Just imagine that I have around 10,000 users. I have fit in a router which has the intelligence of deciding where to route the packets dependent on the user ID from which it is receiving the request. A to H, you could think that 1 to 1,000 user IDs are served here. 1,001 to 2,000 user IDs are served by this replica, and 2,001 to 3,000 is served by this replica. Like that, you would be having n number of replicas serving 1,000 users request. So what we are doing at present over here, that every instance is an order management instance, but we only have a subset of users which get routed to that particular instance. Such type of scaling is called as z-axis scaling. Now coming to the third type, which is the y-axis scaling, x-axis and z-axis helps us in improving capability, high availability of the system, but none of them really help us in distributing or dividing the complex system into smaller, granular, simpler terms, right? So y-axis helps us in doing that. So if you think our application is built up of 3 different components over here, we would be saying that this is x-axis scaling. I'll divide that into, take that out, and after taking that out, so when I'm taking this component out, that is called as y-axis scaling. And here again, I've implemented x-axis scaling. And in case I have a router in front of it and I'm dividing the workload dependent on some application parameter, then I can implement even z-axis scaling. So y-axis scaling works by splitting the monolithic application into subset of services. The word service is what exactly we need to understand that, right? So I have an order service which implements the logic of management of the order which the user places, and we would have some APIs with which other services can communicate with us, like order service client, which would be invoking the orders of create order or looking for an order. If I want to search anything by order, then they would be invoking this REST APIs. And we would have this order service manipulating those requests or going through those requests and tracking the actions according to that. And we could have different even publishers and subscribers as well. Suppose I have someone publishing any data on a queue and I have others subscribing for those. Even that sort of implementations can be done. So when we think the word service, it is nothing but an independently deployable software component. It would have APIs implemented so that others can invoke those APIs and communicate with this. So when we think about microservices, it's like it's a system which is separated into smaller modules that can interact with each other. And the advantages which microservices architecture brings in is that every microservice can be independently updated with patches, with enhancement without affecting the entire system. Just imagine I have a microservice A, I would be packaging that as a separate container. And if I have a microservice B, I would be packaging that as a separate container as well. So you would find that the word container and microservices have been very predominant in the market from the time Docker containers came into the market from 2013, and they have been really popular. Microservices are the way of architecting our application, and containers are the way of packaging and deploying our application. If you always get confused what these two terminologies means and why they are so interdependent and together used all the time, because the way we architect our application is microservices, the way we package and deploy our application is the container way. So the next terminology which we would be discussing in our upcoming video is nothing but containers. So stay tuned for our next video.